Okay, let's look at the APIs, what kind of APIs we would be needing. So our log search application will not allow logs from any service. So, so it should not happen that any kind of a new microservice pops up and they start. Yeah, so I was talking about the register API. So our system should ensure that only registered microservices they can send the logs. So why this is important? So one thing could be that when you are the owner of log search application, right? So at that time, scaling would be one of your biggest concerns. Scaling in terms of that how much throughput you can serve, how many queries per second you can serve, how much writes are happening in your system, right? You need to have some kind of predictability around your storage so that you can scale your systems in advance, right? So to keep these things under your control, you need to have this kind of register API. Otherwise, any microservice that pops up in the company, they can just start writing their logs at some crazy rate and they can bring down your service. So with this register API, you know that which service is sending and unpublished services are not sending the logs, and you can also throttle them. So maybe let's say you know that order service, it's one of the major key services, right? So for them, you can have a more more quota. You can have more quota for them in terms of that how many writes they can do or how much data in gigabytes they can send per day. Now there could be some less important service. For them you can have a different kind of quota. And so this kind of register API also allows you to do those things. Right. Then you can have a publish kind of API, that how the log message is actually being published. So we will look at a couple of ways that how logs actually land up in the system. Right. So let's say there is a publish API at this point of time. Then this is the most critical API, search log. So it could have the so when we registered our service with a service name, we got a service ID. So now whenever any microservice interacts with the log search application, they have to provide this service ID. Right? So the service ID is there. Then you can say that what kind of text you want to search from and to timestamps. Right? Depending on this device, what kind of page size you are sending, continuation token. Right? So continuation token means that this is for taking care of the pagination. Right? So continuation token. So let's say last time you received a log line, you received 100 log lines last time. So next time in the continuation token, you will send this value 100. You will send this value 100. So log search knows that you already have received 100 log lines, so it will send 100 to 200 log lines. In the next query, you will make this continuation token as 200. And so this is how you will take care of the pagination. Then optionally you can send log level, log type, environment, trace ID, right? And then you can also have a tail log here. So if tail log will be false by default, if you are sending it true, in that case, what can happen is that your connection is turned into a WebSocket, and then logs are streamed to the client. Okay. So let's look at the major components in the system. So from the requirements, it's quite clear that we have two kinds of services here. One is the logger service, which collects the logs from the other microservices in the company. And then we have a search service, which takes all the user queries. By user queries means the search queries. So it takes all the user search queries, parses them to understand that what kind of query is being sent, so that it knows what to do with it. Then using that query, it actually finds the results and returns them. Right? Returns the matching results with some kind of sorting. Right? So we have logger service and we have search service. Okay, I'll take a pause at this moment. Let's see if we have any questions. Okay. Now we know that we have two services, right? Now let's try to visualize at a very high level how the system would look like. Okay. So on the left side, these are all the clients, right, which have registered with our service, and they are sending logs. Now for sending logs, for, now let's look at the emitting logs. So for these emitting logs, we can have two kind of systems. One is that we provide some kind of endpoint, and then people can make maybe they can make REST calls or they can make some kind of RPC calls. So whenever they have a log line, they hit our endpoints. Of this sounds, if this sounds bad to you, then yes, this is bad, because if your service is a busy service and if you're writing thousands of log lines, right, then you are making these thousands of calls to this endpoint. So this is really a bad idea. The the actual application, the actual use case of this kind of API could be that maybe, let's say, some software engineer is trying to test your endpoint. They want to test that if I'm able to connect to the log search service properly or not. For that kind of scenario, we can provide this kind of endpoint, but for the practical purpose, this is a bad idea. Right? Okay. If I will talk about the databases now. Yeah. So the second option, what's the second option? So the second option is that, let's say this is my application server, right? One of the application server. So we can have hundreds of application server. Let's say this is one of the application server. So the actual executable, the actual binary is running here, and it's writing to a local log file on the disk. So it's just appending to that log file. Now there could be a agent here, log agent. And what this person is, what this agent is doing, this agent binary, what it is doing there, that it is tailing this log file. It's tailing this log file and putting all those log lines into its own buffer. So let's say there are some new, these green log lines, right? So it will tail them and it will put them in its buffer. When this buffer is full, when this buffer is full, at that time it will hit, um, at that time it will send these to the log search service. Then it will clear the buffer, it will clear the buffer, and it will again do the tailing. It will resume the tailing from the earlier point. Right. Now we said that this agent is taking the content from the buffer and hitting the endpoint of the log search service. Now, if our company is huge, there are going to be hundreds of microservices, and if they all are hitting our endpoints, right? If they all are hitting the endpoints of the log search service, then making the system scalable would be a problem. So what we can do? Now, one thing is very clear from the nature of the problem, from the nature of the functional requirements, that whenever we are dispatching some logs, whenever we are emitting some logs, this microservice, this microservice here, it does not need to bother that how that log was processed. We should just blindly rely on, all the microservices should just blindly rely on the log search service, that I send my log lines to, by I mean, so the microservice sends the log lines to the log search service, and then the microservice can just forget about it. So it's a fire and forget kind of interaction here. So what log search service can do is that it accepts those log lines and parks them somewhere, and then just sends OK. And then it can And then log service can go on with their business, that how they process it. So that is why the messaging queue comes into the picture. Right. Now let's look at the finer detail, that why we use queue. The traffic generated by application services is high, right? The log lines that are being generated by application services is high, and they can have bursts also, unpredictable bursts. So the queues provide us a nice buffering mechanism so that we can rate limit the burst. Then this decouples the application service, means the microservices, right? So it decouples the microservices from the logging mechanism. So if you see, all the microservices are on the left side, then there is a messaging queue, and then everything is on right side related to the logging, right? Now, if one day we find out that okay, our local the our homegrown logging service is not good, we want to redesign it, or maybe we want to go for some cloud offering, right? So we can just replace everything on the right side of this messaging queue, and the microservices on the left side of the messaging queue, they won't even know it, right? So we are decoupling our system with this messaging queue. So this is also one of the main use case of the messaging queue, that you can decouple your systems. And this we already discussed the last point, that application server service does not need a response whether log line was submitted or not, or what processing was done on it, right? So this kind of asynchronous system makes sense here. So they all are writing to this messaging queue. Then we have consumers. These consumers are reading those messages in the queue, processing them, and putting them in some kind of index storage. So this index storage is actually the inverted index storage. And from there, the search service requests are being powered. Could you please explain again what is happening between emit log and message queue? Okay, okay. So what's happening here is, let me draw it again. So what's let's say there is some order service, right? And they have hundreds of application servers running. Okay. Now, if we do a double click on this application this server, particular server, right? What would be happening here? What would be happening here, that we are zooming this, okay, that there is the actual binary of order service that is running, right? Which is actually serving the request from the end users for the order service, right? And in the process, it's also producing logs, right? It also produces logs, and those logs are going into some log file. It could be going into some hourly log file, right? We know that, right? That generally the log files are rotated every hour, right? So these log lines are going to, let's say, some hourly log file. Now what we are doing is that we will have some kind of agent here. So this agent is also a process. It is also a binary which is running. And what this agent is doing, that it is doing a tail. It is doing a tail on this hourly log file. So at every few milliseconds or few seconds, which is a configurable number generally, it goes and it pulls the hourly log file and fetches. So it has also a marker. So it says that, okay, after this marker, what are the new log lines that have come into this log file, and it will fetch those log lines and it will put them into its own buffer. And when this buffer is full, when the buffer is full, at that time it will hit the log search service, and it will publish the content of this buffer to this log search service endpoint, right? And what log search service would be doing, that it will accept this message coming from the microservice. Just a second. Yeah, my mistake. So when this buffer is full, at that time this endpoint, this agent will actually hit the endpoint of the queue, and its message will be put here in the queue. Now, now the consumers are running here, which will, so one consumer will read this message, and then it will talk to the log search service that please process this message. Okay, so what this queue could be? Yes, this queue means a pub/sub queue, right? So a real life example, so it could be a Kafka, it could be a RabbitMQ, it could be ActiveMQ, it could be AWS Kinesis, it could be Google Cloud's pub/sub. Okay, so I hope that question is answered. Umesh is asking, can we assume when service is registered for logs that they are provided topic to push data? Yes, we can assume that, Umesh, that when they register at that time, we create a new topic for them, and that topics, that information is provided to them so that they can hit that particular topic. Yes. Thank you for asking that question. Could you talk about system logs? Like apart from we will also have server logs like CPU, memory, load, etc. So CPU memory load, Natasha, these are not interesting for this use case because our focus is mainly on the log search capability. So in this case, yes, the CPU logs and memory logs, they are also making their way to the log search service in the similar way. So the agent is reading those system log files, and then agent, when the buffer is full, agent hits the a particular queue topic, and then it makes way to the log search service. Then what happens to that is a entirely different use case. Because in case of CPU or memory, what you want to see the pattern, that you want to see the average, you want to see the 90 percentile, 99 percentile, and these kind of things, right? That is a completely different use case. That is a completely different discussion. This is similar to trending topics or the billionth car, that kind of discussion. I hope that answers your question. Is this agent can be like a sidecar container? Yes, if we are running it as a Docker kind of thing, then yes, it could be a sidecar container. If it's a virtual machine, then it's just an independent process running as a daemon. Can we assume that the buffer size is not more than MTU of the network layer? What is MTU, Asim? Bhavika, I hope it's clear now after I just explained it right now, right? So I hope it is clear now, or it's not clear. Please comment. Max transmission unit. Okay. Can we assume that the buffer size is not more than 20 of the network layer? Yes. So actually, yes, the buffer size. We have like two kinds of restriction on the buffer, like condition that when it is full. So one is the size, and then yes, this size is derived from your network bandwidth. So because when you say that your network pipe is fat, right? By fat means you have more bandwidth, so that means you can send more data here. So at that time you can have a relatively more buffer size. When your network capacity is limited, then you will have a limited buffer size. And then this buffer size is also dependent on the time, right? Let's say my network bandwidth is huge, right? So I set this buffer size to, let's say, 100 MB. Now there is some service which has very low number of requests coming to it. So it could happen that that service is able to generate 100 MB of data in maybe 4 hours. So does that mean that for 4 hours we will not send any logs to the log search service? That sounds ridiculous, right? So that's why we have a limitation on both size and time. That let's say my buffer size is 10 MB and I can have a time as, let's say, 5 minutes. So whenever any of them meets the criteria, maybe the buffer size becomes more than 10 MB, or my last sync time has elapsed more than 5 minutes, then this um, the data on the buffer will be pushed. Okay, I hope that answers your question, Asim. Okay, Itua is asking, I'm sorry, but I don't understand the point of the hourly logging. Then the agent reads the hourly logging every X millisecond, then what the buffer is full. Then when the buffer is full, pushes to the buffer. So hourly log file is, it's a very common thing. It was so generally when you write to log files, right? So let's say this is a log file. So you cannot just keep on writing to the same, you cannot just keep on appending to the same log file infinitely, because the limitations will hit, because you have generally you have like a Linux can handle 4 GB of files generally, right? With the new advancements, this limit has increased, but generally cust it it's 4 GB, right? So you cannot just keep on writing to the same log file. And then what happens is, what happens, so what you do is that, let's say you create the log file for the 00 hours, then you create the log file for 01 hour, 02 hour. So let's say when you are writing for the 02 hour, right? So at that time, what you do is that you compress these old files, you .zip or .gz, you compress them so that they take less space on the disk. Because keep if you just keep them lying on the disk, your disk will become full. Once application server's disk is full, it cannot do anything. Right? So to take care of those things, you have hourly log files. And what the agent does is that this agent ties with a file descriptor. And this file descriptor is always connected to the latest hourly log file. So even let's say when the new hour comes, 03 hour comes, so then that file descriptor will be pointing to this new log file. And then this agent keeps on tailing this log file every few milliseconds and puts them in its buffer. And when the buffer is full, so let's say we have limitation on the buffer 10 MB. So when this size is hit, then only we go to the then only we transfer this. Now, if your question is that why we are waiting for the buffer full and then only we are hitting. So if we do not have this buffer mechanism, then that means we would be bombarding the queue with lot of requests, right? For every log line. For every log line, we will be hitting the queue. Now let's say that one log line, we talked about it. So one log line, let's say it's 10 words, and every word has 6 characters. That means it's just 60 byte. Now for every 60 byte, we are hitting the queue. Now what if we had the buffer capacity of 10 MB, right? So 10 MB. Now imagine how many lines we can have in a 10 MB. If one line is 60 byte, imagine how many lines we can have in 10 MB buffer. That means we have minimized all those useless requests going to the queue. So this is the use of hourly log files and the buffer. Okay. Thank you, Asim, for that question and providing the information. Sneha, so we are solving the problem of endpoint being hit too many times by batch. Yes, Sneha. Do you really go deep in interview setting? Yes, it's a fair question, Asim. So, why do you come up with the buffering strategy? So, if you like as an interviewer, I will be interested in knowing that when like if you come and say that okay, my agent is running and I will keep all those things in buffer and then I will push. Then I will ask you. Definitely, I will ask you just to check on your knowledge that maybe you have just heard about the buffering or you actually know that why you are using buffering. That is why we also discuss that why queue is being used right here. We actually made a case that why we are using queue. It's not that okay, I've heard that messaging queues are cool, so I'm just going to use in my design. Log files are hourly log files usually, Asim, and then and they can be split on the basis of size also. So you have like 1 hour or 4 GB. So 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 let's say if your service is bombarding logs and writing them to this log file, right? So let's say in 20 minutes you fill 4 GB. So at that time, again, the operating, we define these rules at the operating system level. So the operating system will create a new log file whenever this 4 GB is full or whenever the 1 hour passes. No, that was for different thing, Asim. You are saying that assume that I mentioned that 5 minute and 10 MB for the buffer size. Where did it go? Here. Right. I mentioned it for the buffer size. If you're confused, I will write it again. So for buffer, you can have like maybe like 10 MB or maybe 10 KB kind of thing. And you can say 1 minute or 5 minute. For the log file, usually you have 1 hour or you can have 4 GB. But don't you have to choose between the two size or time? I didn't get your question also. Well, we provide both the things. So whenever any of them fulfills, we just make it. Buffering already explained Asim just now, right? That with buffering we are limiting the number of calls that we are making to the queue. If we do not have buffering, then we'll be making thousands of calls to the queue. Right? Here, here I explained just now, right? I explained here, right, that if we have only 60 bytes of one line, and for every 60 bytes, if we hit the queue, that means we are sending thousands of requests. Now, if our buffer size is 10 MB, then I'm minimizing those calls to the queue. Can you explain a bit more about what do you mean by burst? How does queue help? So queue helps here, right? So these queues, they have a lot of storage capacity. So okay, let me write here only. So imagine this design without queue. Let's say 1,000 requests per second come to our system, to our service. Right? Now we say that one commodity server can handle 250 requests per second. So so with that in mind, I will have just four servers here. Now, if there is a burst means there is an unexpected increase. So due to this sudden increase, let's say it becomes 2,000 requests per second. Now, definitely my system, okay, my system is, okay, let's say we are running at 40% CPU. So, okay, so 2,000 requests, even if they become double, my four servers can handle them. But my CPU will shoot up to 80% now, assuming my service is CPU bound. What if becomes 3,000 requests? At that time, these four servers will not be enough, right? If they are not enough, then what should I do? In that case, I should increase more servers here. But increasing more servers takes time. By the time those new servers are being added, my service will be unavailable for a short time, right? Now, imagine if we had a queue here, and that queue also comes into the picture only when I know that the client is okay with the asynchronous responses. Right? So then only I can have a queue, because if people want real time response, then I cannot have the queue. Right? So now if we take example of this log search, right? Now if 3,000 writes are coming to the system suddenly, right? So if I have the queue here, I have a cushion here. This queue is nothing like a buffer, right? What I'm doing is that whatever extra requests are there, I'm just parking them here. Let's say four messages are coming to this queue, and my system is capable of processing only two messages. So I will remove these two messages, and I will process them. And the other extra two messages are still lying in the queue. I'm not bothered about them right now. Once I'm done with these two messages, I will take these two messages as well and I will process them. So Sneha is asking, I'm little confused between the relationship of the hourly log file and the buffer. Uh, Maybe Sneha, we can take it again at the end of the session because we have already gone through it 2, 3 times. So because we still have a lot of material to cover. So I'll keep this question open so that we do not forget it. Can you achieve real-time service without the use of queues? Yeah, let's take this question at the end, Asim. Who are the consumers in this regard? Can you describe the subscription portion that leads? Consumer means the processes that are processes that are consuming the message from the queue. So they are the consumers. Can you describe the subscription portion that leads to the index storage? Yeah, we will come to that. We'll come to it. That's what I said. Like we still have a lot of things to cover. Please put your votes in the poll. It helps me also personally as the instructor. So if I get your feedback, I can improve next time. Okay, there is no new question. Okay, let's move ahead. Okay, so this emitting logs we have already discussed in detail. That we can make some HTTP calls or there could be some agent running. Let's move ahead. Then we can have some kind of log filtering mechanism also in the service. That if we are receiving some from some unauthorized service or from some unauthorized environment of a registered service, or if some kind of garbage is coming into in the log messages, in that case we can just discard them, filter them. Yes, now comes the important part, the searching logs, that how do we search the logs. So basically we need to have some kind of efficient data structure so that these logs are searchable. And the search request, the query which is coming, they can have some kind of text that okay, this text should be present in the logs, or it could have some field names, right, that I need for this service or I need for this timestamp only, right? So we need to have some kind of data structure to support the efficient searching of the logs.
Want to become a software engineer at Google? You can, like thousands of our students. You just need to learn from those who've already cleared FANG interviews. At Interview Kickstart, our interview prep courses are developed and taught live by 150 plus instructors from Tier 1 companies like Google and Facebook. Our courses are tailored to help you crack software engineering domain interviews, including back-end, full stack, machine learning, embedded systems, data science, and more. To learn more, book your free webinar slot today